2012 test, number 91. So what is this chart telling you? It's giving you the values of the derivative. So I want to emphasize that. This is the derivative of x. Now, here's the common mistake people will make. They will make assumptions about this graph. They're going to look, oh, the derivative is 3, then it's 1, then it's 4, then it's 7, then it's 5. Some people might say, oh, the derivative is always positive. But that's not true. You do not know what's happening between these 2 points. The derivative could go from 3 down to -5 and back up to 1. You don't know what's happening between those. So don't make assumptions between those points. Be careful about that. That's where most people mess up on this. They assume things about the graph that's not necessarily true. So the first one is the graph of f concave up. In your brain, you should ask yourself, is the second derivative positive? Always. And you might say, this doesn't tell us the second derivative. How am I supposed to figure that out? But watch this. The derivative goes from 3 to 1, right? It drops. That means at some point the derivative is decreasing. If the derivative is decreasing, its derivative must be negative. In other words, the second derivative must be negative between these points. That contradicts that. So definitely false, because we know there's a point where the second derivative is negative between those points. You can use the mean value theorem for that. That would be proper. If you find the average rate of change, the slope between those 2 points, it's negative. Therefore, there must be a point where its derivative, the second derivative, because the derivative of the derivative, second derivative, is negative. So mean value theorem would prove that that is definitely false. Letter B. The graph of f has at least 2 points of inflection. Okay, let me walk you through this. If you find the slope between those 2 points, it's negative. By the mean value theorem, the derivative of this must be equal to that negative value. So I know at some point the second derivative must be negative. Now look between these 2 points. If you find the slope between those 2 points, the average rate of change, f of b minus fa or b minus a, it's going to be positive, right? So if the average rate of change between these 2 points is positive, by the mean value theorem, there must be a point where its derivative equals that positive slope. So the derivative of f prime is f double prime. There's got to be a place where f double prime is positive. We're going to continue down the line. Let's look at these two. Well, if you take the average rate of change, it's going to be positive again, because 7 minus 4 is positive. So it's going to be a positive. Therefore, by the mean value theorem, there's got to be a place where the second derivative is positive. Now, it could be negative at points. We don't know that, but this is what we're guaranteed. And then we're going to look at the last interval, these two. If you look at the slope, it's going to be negative, because why? 5 minus 7 is going to be negative. F of b minus fa is going to be negative. So by the mean value theorem, there's got to be a point where the second derivative equals that negative slope. So here's our conclusion. The derivative had to change from negative to positive at some point between those, right? That's an inflection point. And the derivative had to change from positive to negative at some point. That would be an inflection point. So it appears that that is our true statement. Let's keep going though. Let's check all these out because we're going to learn something by looking at all of these. Now, here's where a lot of people get tripped up. They look, oh, f is increasing. What's the justification for f increasing? That means the derivative must be positive. And then they look and say, oh, positive, 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 positive. Derivative's always positive. True, true. Remember what I told you earlier. You do not know what's happening between these points. It could go from positive 3 down to negative and back up to 1. It could have been negative between those. You can't assume that. They're just giving you the values at specific points. They're not telling you what's happening between those points. So it might be true, but it doesn't have to be true. That's false. F has no critical points. Is that true? It might be true. And once again, you might look 3, 1, 4, 7, 5. Huh. A critical point where the derivative is 0 or does not exist. Look, the derivative is never 0, so no critical points. Again, you're assuming. You don't know what happens between these 2 points. The derivative could have went from 3 back to 0, back up to 1. So since you don't know, you can't state for sure that it has no critical points. It might not have critical points, but it might have critical points. So you can't say for sure, must be true. And F has at least 2 relative extrema. Well, where do relative extrema occur? At critical points, right? Well, we can't even prove this has critical points. And then on top of that, what's the justification of relative max? Derivative change from positive to negative. What's the justification of relative min? The derivative change from negative to positive. Can I prove that the derivative changes from positive to negative or negative to positive? There's no way, because it's positive everywhere on that. So it has at least 2 relative extrema. There's no way to prove that. That's not always true. Technically, it's not a false statement, but it's not always true. But my F's, I put false, but technically not always false, I should say.